In this tutorial, I'm going to show a couple of region and PSF related things. There's a nice pretty image. We're going to look at a couple of the coordinate tasks. The first one is I'm going to display the Chandra field of view. This runs the SkyFOV tool. And you can see it draws basically a polygon around each detector or each chip. This is useful especially if you have a source at the edge of the field where you need to be careful about accounting for the area that may or may not be exposed. So I'm going to go ahead and delete all of these. Now I want to focus on this source over here. It's a nice bright source. The optical axis is going to be somewhere over here. You can kind of tell just by the size of the individual point sources around here. This one, it looks kind of interesting because it's pretty big and pretty bright. So we're going to focus in on over here. And I just want to get the coordinates for this guy, so make sure I'm in edit region mode. I'm going to center this on here and change our coordinates. And it's going to show me that I'm actually on chip 0 with these chip coordinates. Sky, RA's index, and kind of the useful thing is it's 9 arc minutes off axis, which is pretty far. The PSF has gotten quite large here. So we might actually want to ask the question, okay, so the PSF is big, how big is it? Well, there are a couple of Chandra PSF tasks that are now available here, and I can ask the question, you know, how big is this circle? You know, what fraction of the PSF does this circle enclose? So I can do PSF fraction. And the trick is the Chandra PSF varies with energy, so I have to pick an energy. So I'm going to use the default 1.5 kV. And there we go. So at theta phi with the radius of this big at 1 kV, 1.5 kV, the PSF fraction is 98%. I can kind of ask the other question, which is what is the, you know, let's say I wanted something that's 95%. So energy 1.5, PSF 1, and it's going to show me, or it's going to draw for me a second region, which is now the 95% circle. I can actually do something like, let me, oops, let's zoom back out here. Zoom to 1. Let me delete these guys and start over here. Oops, histograms and close count fraction. So what this is doing is it's starting from the center and showing me the integrated flux out to 100%. So it assumes that this radius we're 100%. So what's the profile? This is a useful way of looking for variations in the PSF in an integrated sense. And lastly, since we keep talking about PSFs, I can actually go ahead and just simulate the PSF here. So simulate the PSF, 1.5 kV, flux. You can play with these different parameters to try to optimize the simulation. And you can see it runs the simulate PSF task. These are all your files will be located in this directory with that root name. So we now have 2 DS9 frames, so I can do something like frame match frame on WCS. And now when we switch between them, you can see something looks a little off here in the sense that it doesn't quite look like the PSF. So there probably are two sources here that are being confused.